Hello and welcome to the EEPROM 9. Today we have teardowns of Geiger counters, or more specifically, and to be more correct, dosemeters. These are two dosemeters I got quite a while ago. This one's actually I've had the shortest, and this one I've had since uni. And in fact has had the same batteries in it since uni. And if you look at the display, you can see it's a little on the washed out side, so they kind of need replacing. But you can also see we've got a dose of 10,585 USV. That is roughly, I don't know exactly when I got it, I can't remember. But if we punch that into the calculator, 585. Divide about 3,000, because that's what we got a year. That's roughly, really, 3 years? Maybe it's 2,000. Yeah, let's go with 5 years, because that's a pretty accurate guess for uni. It's probably actually a bit more than that. Divide 5. Yeah, that seems a bit more. Yeah. Screw the maths. My brain's not doing maths because migraine. But brain can do electronics because brain can always do electronics. This is my other one. This one is a bit of a weird one. Resetting it, the dose is an absolute bugger because when it hits the 150 USV, it will just beep continually non-stop. The way to reset it, and there's a bit of a knack to it, is you have to push this button like repeatedly several times really quickly, like a million times, just loads of times. Then you have to hold it, remove the battery, leave the battery out while still holding this button, and then keep holding the button, leave it out for say roughly about 10 seconds. Reconnect the battery, keep holding it, push this to switch it on, and then you can release this once it's in this booting process. And that usually resets it. I'm getting it to be reliable now, but that's not the subject of this video. It's Dosemeter, so he can go over there with my Garmin sat-nav. And the Swiss Army knife isn't going to be used in this video, it's just kind of chilling there because, well, that's where it's chilling. I also added in this screw rather than electrical tape to hold it in. We'll actually put it where it is actually in focus, the cap. Now hopefully I won't get a shock off this because I'm not going to discharge any caps. If I do, it's going to be very minor. So out comes that. Standard AA batteries. This is from Appleford Instruments, a now unsurprisingly defunct British company, because just about it seems to be the case that just about every single English engineering company these days seems to be fucking defunct, which is just depressing, especially when you consider the amount the UK contributed to it engineering throughout the ages. We've got currently a current dose of 10,585. I want to say that on video so I've got some record of it, because when you take the batteries out, unsurprisingly he forgets the dose. Although not straight away, although that's just the caps going down. Yeah. Has he still got the dose now? Yeah, he's still got the dose. Somehow. So yeah, out he comes. Actually, I have taken this apart in the past when I first got it. But I looked through my YouTube history and it didn't look like I'd done a video on it. Mind you, I haven't done a video on taking this one apart. Not that there's much to see in there because most of the electronics are covered in rubberization, but I removed it where possible. Let's just adjust the focus a bit. There it goes. This makes a good angle for doing this. I've got the Undertale music stuck in my head because I've been playing Undertale a lot lately. It's good fun. So we undo the screw, we screw the Geiger counter. Because as we know, we like screwing stuff on the EEPROM 9. Screwing stuff is much fun. Oh, there's a joke I could have made there, but that's probably, yeah, that one might actually get me in trouble. because that goes into my severely dangerously dark sense of humour that's like really, really, really fucked up. Like, worse than dead baby jokes. So, out he comes. Now, shall we test whether there's voltage stored up on this? No tingles on the finger, so it's all good. Now, this is actually quite an old design when you look at this circuit board. Look at this. It doesn't even look like it was designed on a computer, just with how the traces are rounded and almost like hand etched on. Angle it to the light a bit better. Now we got that weird marking there. So let's actually take this board out. The little Geiger counter is there. You can just about see it there. I think it's meant to be purely a gamma one. It looks like I'm going to have to take these off, and there's a flat head. I might not have to worry about the flat head actually. That might just be... Oh yeah, that's no surprise. Look at the quality you get now. You get good audio quality, you get good... Have we really been going 6 minutes already? Who'd have thought? Oh no, that little screw does need removing. Oh, we might need the Swiss Army knife after all. Only because I can't be asked to get the flathead from the other end of the room. Looks like there's at least a minimum of 3 ICs in this thing. I'm curious to when they're from the age of the board. Could this be 70s? Ah, there we go. Oh, I didn't need to remove that screw. Nope, it's 80s. We will pop him back on because he is very delicately, yeah. Very delicate wires. Yep, that's going in. Hang on, is that 2 Geiger counters? That'd be an interesting design. The only Geiger counter I have that has 3 tubes in it is the DP, is it 60, 70? Yeah, I think it's 77. So yeah, 4011B NAND chip. Hey! There's one I instantly read. That's a quad NAND chip. And just in case I'm wrong, but I actually remember doing a lot of research on these from back in the day, 11. We got a, whatever that is, and we've got the one under the LCD. We might... No, the LCD's soldered down, so removing that's going to be a bit difficult. There we go, 4011. There you go, quad input NAND chip. What a surprise. Well, not quad input, but quad NAND chip. Standard 2 inputs. So yeah, let's peel him off. No, it's just a single tube, but interestingly, it's got this little plastic divider in the centre, which is something you don't normally see. But yeah, the date code on this is 8411, and interestingly the date code on this chip is 9334. So you've basically got a decade gap between these 2 chips, and I don't see any obvious signs of a repair during its life, so I'm not sure what's going on there. That is quite interesting. Maybe using old stock parts. That does occasionally happen, but well, I wouldn't expect parts to stay in stock for that long in an industrial environment. There's the annoying little beeper. And really there's not a huge amount in it, just jelly bean components. I mean the NAND chip doesn't actually seem to link. You can see that the output of the Geiger counter goes into the coil here and is actually shielded and then picked up. It should be picked up by a resistor. Normally that's how they do it. Oh, that's a bit nasty. Look at that. The ferrite bead thing has got a section missing on it, so obviously got dropped in its lifetime. You can also see the coil. But yeah, the cap goes to the other side. Ah, so yeah, this uses the cap. The diode, yeah, that's just going to be to make sure it's got DC to the tube, because they're actually DC devices. Yep, that is exactly how it should be. Negative there and then positive going to this part. But interestingly, here's where the signal was actually pulled off. So the high voltage is put in at this end. And then, yeah, and then there's the resistor, which isn't actually as high value as you think it is. I mean, I don't know the resistor colour code off the top of my head, but that's not in the crazy high values that you normally do for these. That goes into, surprise, surprise, that resistor. Through that cap. Ah, yeah, okay, so that actually, signal actually goes into this chip up here, the mystery brains of the chip. This will probably be an ASIC based on the age of the dosemeter. And then the beeper, transistor, yep, as I suspected. That's the beeper driver. That drives the little piezo beeper. The signal from the chip actually goes out through here. I'll see if I can lead you on. Comes out through there. Routes round to there. Which goes through this little capacitor here. It's difficult to follow actually, because at first yeah, interesting. It goes through that resistor off to the ground, and also, so that's obviously a reference thing, into this capacitor, which leads back to down to the ground plane, and also up to vias, which inevitably go, well, the vias go nowhere, but there is a pin that goes there and then up into the chip there on that pin, and then another resistor, which obviously, so one side's obviously, yeah, one side's negative, one side's positive. Which side is it again? Positive, negative. Okay. No, yeah. Oh, that side's the positive. Okay. And that side's the negative. Okay, okay, so that's the negative side. Okay, I got that a bit wrong. Oh well. But that's the general gist of it, so yeah. Beeper. I'm not sure what they're doing with the NAND gate. I'm guessing they're just generating the oscillation signal for the piezo speaker. That would be my guess. They're just using it as an oscillator, because you can actually do that with NAND gates. In fact, it actually very much looks like they might just be doing that. It's difficult to tell, but yeah, there's not much else I have to say about it really. Thanks for watching. Hope you found that interesting. Neat little bit of tech if you ask me, and I will put it back together and I don't know, I'll stick it back wherever it was hiding. It used to live in my lab coat, which is behind my door. Thanks for watching.